Hi friends, it's Mrs. Jackson. I want to walk you through some additional nuclear decay practice problems. These actually came from a practice set that was published in Schoology last week, but there was some confusion on how to work through some of the problems and how this was going to be assessed. So we're going to clear up the confusion on how to work some of the problems, and there will be a homework quiz over the information or over the practice problems in the link that is with this lesson. It was also provided last week. You will need to complete all the practice problems first, because when you open up the quiz for the homework quiz, it is timed. It's a very short quiz. It is designed so that all you have time to do is to look at your paper that is already completed and then enter the number values or the symbols that you find there. So definitely need to have it completed before you begin the quiz. So if you will take out your practice set of problems, they are your nuclear decay set. They look like this. This is an image of your nuclear equation set that you should have opened up. I recommend having it printed if possible, but you can edit a PDF and you will be able to use that as well. So double check that you've got what you need before you begin the quiz. So let's go through some of the examples for some of the problems that students find maybe a little bit more challenging. Hopefully you remember from your previous lesson that the three common types of nuclear decay that we look at are the alpha decay, which is a helium nucleus, the beta decay, which is essentially an electron, and gamma radiation, which has zero mass and zero charge. Those are the three common types of nuclear decay that we look at, but there are a couple of other things that we looked at through the notes that will play a role in the homework assignment that you have to complete. So you definitely are going to want to have your note guide from nuclear chemistry out as you work the problems for today's practice set. So I'm actually going to take you through a few of the problems just to give you some more examples before you get started and to help you with some of the pieces that some students occasionally find troublesome. So if you've got your paper ready, these examples on the Jamboard actually come from today's homework assignment. So we're going to work through a few of these, get you started, and then let you finish the rest on your own. So the first one that we're going to look at is number 1. We're going to start at the top and we're going to look at a type of radiation. When I look at my particle here in the practice problem, I see that I've got a helium nucleus. So this is an example of our alpha radiation. So what I want to do is I want to fill in this remaining blank. So the process that I'm going to show you is going to be the same process for all of the practice problems. It will vary in some ways, but in general it's going to be the same. So what I want to do is I want the top numbers, my arrow, remember, is my halfway point. So I want the top numbers on the left to equal the top numbers on the right. So on the left, in the mass number position, I've got 9 plus 1 on the left. So my mass on the left is 10, and on the right, I have 4. So I have to figure out, what do I add to 4 so that it equals 10? And the answer is 6. I'm going to do the same thing with the numbers that are in the denominator. So in the bottom, I've got, let me see if I can highlight it. Maybe that will work better. In the bottom, I've got 4 and 1. So I have 4 plus 1 is 5. On the right-hand side, I have 2. So I want to figure out, what do I add to 2 so that it equals 5 on the left-hand side. So again, on the left, I have, let me change that from a highlighter. On the left, I've got 4 plus 1 is 5. On the right, I have 2. So to fill in the blank, I have to have 3. 3 plus 2 is 5. and that matches 4 plus 1. When I look up element number 3 on the periodic table, it is lithium, and that solves that problem. So this idea that we're going to look at the two sides of the arrow and make the top numbers equal and the bottom numbers equal is how we're going to solve all the problems. So when I look at number 2, again, this is an alpha problem because I've got my alpha particle on the right-hand side. Now notice in this case that the blank is on the left, but it isn't going to change how we solve the problem. The process remains the same. So on the left, I look at the mass number. I've got 27 here, and I have a blank. On the right-hand side, I've got 24 plus 4 is 28. So on the right-hand side, the mass numbers add to 28. On the left-hand side, I have 27. So what do I add to 27 so that it will equal 28? The answer is obviously going to be 1. Then I followed the same logic for the bottom. On the left-hand side, I've got 13. And on the right-hand side, I have 11 plus 2 is 13. This doesn't change my process. What do I add to 13 so that it equals 13? Well, that's easy. I add nothing. And so this bottom number is a 0. And if you think back to our subatomic particles, we looked at a particle that has a mass of 1 but has no atomic number, and that is the neutron. So this is filled in with the symbol N for neutron. So that's something that was in the notes, but it wasn't one of the types of decay. So I want you to see that and see what it looks like. Sometimes to get these atoms like aluminum 27 to fall apart or to decay, we bombard them or they get hit with a neutron, and that causes a type of split. Okay? Same process, just it looks slightly different. Now let's take a look at number 4. Number 4 is a different kind of decay. Notice I don't have a helium nucleus here. I have an electron, and that's a completely different type of decay. If I look at this other type of decay, that's actually a beta particle. So, oh dear, that is my beta particle here. So when I look at my whiteboard, and I solve my problem, it's going to be the same process, but I have to look at my numbers really carefully, because this time instead of having whole round positive numbers, I have whole round and a negative value. So to solve this one, I'm going to use the same kind of logic. I still look to the left and the right, and I have to make the top mass numbers equal, and I have to make the bottom atomic number equal as well. On the top left, I've got 42 in the mass position. On the right, I have a 0. So that's easy. What do I add to 0 to equal 42? And the answer is 42. The bottom number, not any more difficult, but you have to be careful. On the left, I've got 19, and on the right, I have a -1, so you have to be careful. In math, you should remember that adding a -1 is the same as subtracting a +1. So adding a -1 is the same as subtracting 1. So what number do I begin with so that when I subtract 1, I have 19? What -1 is 19? And the answer is calcium, or number 20. When I look up number 20, not a big surprise, spoiler alert, it's calcium. And that's how you work a beta decay. It's the same kind of problem, but you have to be careful with a negative number value, that's all. All right, next up is number 8. I chose number 8 because it's got both a beta particle here and an alpha particle here. Solving the problem, it doesn't change. There's just another particle on each side to look at. So again, I have to split this down the middle. When I look at the left, in the mass position, I've got 6 plus 1, which is 7. And on the right, I've got 0 plus 4 is 4. So what is it I have to fill in the blank so that when I add it to 4, it's going to match 7 on the other side? Well, 4 plus 3 is 7. Okay, so the same process. Now I have to look at the bottom numbers, and 3 plus 0 is 3. And then on the right, I've got the -1 plus 2. Well, again, adding the -1 is like subtracting 1. So 2 minus 1 is 1. And what is it I add to 1 so that it equals 3 on the other side? Well, 1 plus 2 is 3. And then I look up element number 2, and it's our old friend helium. Not an alpha particle because he's not helium with a mass of 4. He's just helium with a mass of 3. Same concept, just a little different twist. 2 particles instead of just 1. All right, let's look at 11. 11 is the same idea, but instead of having 2 particles, I've got this new twist, and it's called the coefficient. Just like a coefficient in algebra means I've got 2 of whatever is behind it. The coefficient in this equation is the same. I have 2 of the hydrogen isotopes behind it. So from there, the process remains the same. I have 3 plus 3 on the left, which gives me 6. On the right, I have to remember to double it because I've got a 1 in the mass position, but there's 2 of them. So 2 of them that weigh 1 is 2. So to fill in the blank, what plus 2 will equal 6, and the answer is going to be 4. And then I follow the same logic on the bottom. 2 plus 2 is 4. And then over on the right, 2 of the hydrogen, so 2 times this 1. I've got 2 of them that weigh 1, so that's 2. And 2 plus blank is 4, and the answer is 2. So then I fill this in with the symbol for helium. Okay. So the process is so very much the same. There's just a few things that make it look like it's maybe different. All right, let's take a peek at 2 more, and then I'm going to turn you loose to finish your own practice. All right, let's look at 15 and 18. Actually, I may look at a couple more beyond this, some word problems just to get you started. All right, same concept. This just looks a little bit bigger, so you're still going to look at the 2 sides. This one has the blank on the left, but it doesn't change how I solve the problem. So I've got 1 on the left, so that's not very big and not very helpful. So on the right, I've got 142. I've got 91. And here is my old friend, the coefficient. So I've got 3 of these neutrons. Well, 3 of them that weigh 1 AMU apiece gives me a total of 3. So when I take my mass, I've got 142 plus 91 plus 3. So that is 6, 3, 2. 236. Should be right, if my math doesn't fail me. So I've got 236 on the left. What do I add to a 1 to make it add to 236? Well, the answer is simple. It's going to be 235. And then I follow the same logic on the bottom. I've got 56 plus 36 plus 0. 3 times 0 is 0. So 56 and 36 is going to be 92. So this becomes 92. I look up element 92, and that is a sad looking U for uranium. So the last item on this slide is number 16. So we look at number 16, and we're going to solve it the same way. Here is my arrow, so that's the dividing line. On the right hand side, I've got several items, and I've got 2 coefficients. I've got a 2 in front of the alpha particle, and I have a 2 in front of my beta particle. And then I'm going to finally wind up with 1 single product for my blank. So on the left, I've got 214, and I'm going to add to that the mass of 2 alpha particles. So 2 times 4 is 8. So I've got 214 plus 8 plus 2 times the mass of an electron. Okay, 2 times 0 is 0. 214 plus 8 is going to be 222. 214 plus 8 is 222. So I know my top number here is 222. And then I do the same in the bottom. I've got 84. I'm going to add to that 2 helium or alpha particles here. 2 times 2 is 4. And then I've got 2 of my betas. 2 times -1 is -2. So when I add all that up together, 84 plus 4 is 88 plus -2. Remember that adding a negative is like subtracting 2. So that is 86. Okay, so then I put in 86 as my atomic number, and that should be right on. That's how you solve those problems. It's filling in the blank, and we just use some simple math. Okay, so just take your time, work with your numbers, and be very careful as you're using those negative signs. For the next two examples, I want you to look at 21 and 26. These are the same kind of problem we've just looked at, but they are in word format. So we just need to take the words and write them into an equation that looks like what we just practiced. So on number 21, we've got hydrogen 3 breaks down to form a beta particle in another element. So this is going to be what I start with because hydrogen 3 is breaking down. So I'm going to start by writing hydrogen 3. So I use the chemical symbol for hydrogen, which is H. The 3 tells me its mass is 3, and that goes on top. And because it's hydrogen, when I look at the periodic table, I know that my element number is 1. So this is how I start. And it tells me it breaks down to form a beta particle. So my symbol for a beta particle, remember, looks like this. So it is a 0 over a -1. You can also use the beta symbol if you are so inclined. I'm going to use the 0 over the -1 with the E, just as a reminder to you it's an electron. And then it says it forms one other element. So that's where the blank would be. So once we have that information and we're ready to go, then I follow the same process we've been using for all the other problems. And I can't draw a straight line to divide this in half. Save my soul. All right, on top I've got 3 on the left, and on the right I've got 0 plus blank. So this is an easy one. 0 plus 3 equals 3. And then in the bottom I've got a 1 on the left, and then I have a -1 on the right. So remember that we're actually, when we see the -1, we have to remember we're subtracting 1. So what number do you begin with? Subtract 1 to find an answer of 1, and the answer is 2. 2 minus 1, or 2 plus -1, is 1. When I look up element number 2, we find that that is helium. And then I'm finished. Number 26 is very similar, but you have to read it much more carefully. The question reads, alpha emission by plutonium-242. When you read it carefully and you see alpha emission by, what that means is that the alpha emission is happening where it's coming from. That is not a highlighter, folks. That is a magic marker. When you look at the wording, alpha emission by plutonium, that means plutonium is the starting substance. So we have to read the sentence carefully to understand what our beginning material is, plutonium-242, and what is happening to it. You have to read the sentence and not just write down the words in the order they come in the sentence. So plutonium-242, plutonium symbol is Pu, so I start there. Its mass is 242, and I put that up top. Plutonium, when you consult your periodic table, plutonium is down here, number 94. So I fill in element number 94. And then I'm ready to start my decay. All right, so it tells me it's going to be alpha emission. So when I go back and I look at what an alpha particle is, this is that helium nucleus. So I write my mass of 4/2 with the symbol for helium, or you can use the alpha symbol, whatever suits you. And then we have another element, because remember the sides have to be equal. They have to be the same. So I've got plutonium-242 going through alpha emission or alpha decay. So now I just figure out my sides, my halves. 242 on the top half. On the right, I've got 4 plus blank gives me 242. Well, the answer is going to be 238. 238 plus 4 gives me 242. And what do I add to the number 2 to equal 94? And the answer is 92. And when I look that element up, again, a sad U. That is uranium, uranium-238. So that's how you solve some of the problems on your problem set that look a little bit different. Please go in and practice answering those. You'll need your entire set of practice problems completed before you complete the homework quiz. It is timed and it is short. So be very careful. Do your work very cautiously. Take your time, get them done correctly, and then take your quiz. Please don't hesitate to reach out if you have questions. I'm always here to help. You just have to ask. Talk to you soon. Bye.